Okay, so we have completed till 7th question of exercise 4.3. Now we'll be continuing with the 8th question. Okay, 8th one. In countries like USA and Canada, temperature is measured in Fahrenheit, whereas in countries like India, it is measured in Celsius. Okay, here it is a linear equation that converts Fahrenheit to Celsius. So the equation is F is equal to 9 by 5 C plus 32. Okay, so what you need to do here, you need to first of all you need to draw the graph of the linear equation above using Celsius for x-axis and Fahrenheit for y-axis. Now we'll do this one. F is equal to 9 by 5 C plus 32. This was the question. So here you need to consider Celsius for x-axis, Fahrenheit for y-axis. Okay. So instead of x and y, here we have F and C. Okay, the same way we will find points because we need to plot it in the graph. First of all, I am taking C equal to 0. So when C is equal to 0, you can write F is equal to 9 by 5 into 0 plus 32. Into 0 means this got cancelled. So F is equal to 32. So your first point is 0, 32. Okay. Now you can take, suppose I am taking next C equal to minus 10. Okay. What is the value of F? F is equal to 9 by 5. C is minus 10 plus 32. 5 2s are 10. 9 into minus 2. Minus 18 plus 32. So what is minus 18 plus 32? That is 32 minus 18. 14. So you got the next point as minus 10, 14. That's enough. We'll plot it in the graph. Points are 0, 0, 32, minus 10 and 14. Okay. Since we have bigger values like 32, 14, 10, I'll take 5, 10, 15, 20, 25, 30, 35 like this. 5, 10, 15, 20, 25, 30, 35. Minus 15, minus 20, minus 25, minus 30. Minus 5, minus 10, minus 15, minus 20, etc. So our first point is 0, 32. So 32 in the y-axis. So this is your y-axis. 32 will be somewhat between 30 and 35. So somewhat here. So this is your first point, 0, 32. Okay. Now the second point, minus 10, 14. Minus 10 is in x-axis. So your x coordinate is minus 10. You can take x-axis minus 10, that is here. Y-axis 14. 14 will be somewhat between 10 and 15. So here, right? So I'm joining this one. Here, this is your point, minus 10, 14. Okay. So you can join those points. This will be the line. This is your graph. So first sub question is done. Come to the second one. Okay, second. If the temperature is 30 degrees Celsius, what is the temperature in Fahrenheit? Easy. You can substitute C as 30 degree. In this equation, put C is equal to 30 and see what is the value for F you are getting. Okay. So this is the equation. F is equal to 9 by 5 C plus 32. Okay. Now you are substituting C is equal to 30. Therefore, F is equal to 9 by 5 into 30 plus 32. I can cancel this. 6 5s are 30. 9 into 6, 54 plus 32. What is 54 plus 32? 86. What? 86 what? What do you get as 86? F is equal to 86. So you can write 86 Fahrenheit according to the question. You got the value of F as 86. So you can write 86 degree Fahrenheit. Now come to the third sub question. So third one is, if the temperature is 95 degree Fahrenheit, what is the temperature in Celsius? So we need to substitute instead of F 95 and see what is the value of C. Okay. F is equal to 9 by 5 C plus 32. So we are substituting F is equal to 95. Okay. Therefore 9 by 5 C plus 32 is equal to F. F means 95. Okay. So I am taking this 32 this side. So positive 32 becomes negative. 9 by 5 C is equal to 95 minus 32. What is 95 minus 32? 63. Okay. So we can write 9 by 5 C equal to 63. Okay. In the next step, I am taking this 5 this side. So divided by 5 will become into 5. Division will become multiplication. I can write 9C is equal to 63 into 5. 63 into 5 is 315. So you got 9C is equal to 315. Then what is C? C is equal to 315 divided by 9. Okay. Then you will get the answer as 35. 35 what? What is the degree? What is the unit? This is C. So degree Celsius. Now come to the fourth sub question. If the temperature is 0 degree Celsius, what is the temperature in Fahrenheit? And if the temperature is 0 degree Fahrenheit, what is the temperature in Celsius? That means first we'll put C is equal to 0. Then we'll see the value of F. And then we'll put F is equal to 0. We'll find the value of C. Okay. So first C equal to 0. F is equal to 9 by 5. C is 0 plus 32. Cancelled. F is equal to, what is remaining? 32 degree Fahrenheit. Now you can put F is equal to 0. That means when F is equal to 0, put F is equal to 0. In this equation, F is equal to 9 by 5 C plus 32. I am putting F is equal to 0. Okay. So 9 by 5 C plus 32 is equal to 0. 9 by 5 C equal to, I am taking this 32 this side. So minus 32. Okay. I am taking 5 this side. So divided by 5 will become into 5. 9C is equal to minus 32 into 5. 9C equal to minus 32 into 5. Then what is C? This is multiplication. So when 9 comes this side, it will become division. Minus 32 into 5 divided by 9. Okay. If you solve this one, you will get minus 32 into 5 minus 160 divided by 9. Minus 160 divided by 9, somewhat you will get 17.7777. Okay. This is your C, degree Celsius. Or you can write 17.78. You can stop here. Instead of 17.7777, you can write 17.78 degree Celsius. Now the last one, last sub question. Is there a temperature which is numerically same in both Fahrenheit and Celsius? If yes, we need to find it. Okay. Is there a temperature which is numerically same? How will we find it? Numerically same both in Fahrenheit and Celsius means F is equal to C. They are telling they should be equal. Same in Fahrenheit and Celsius. So you can take F is equal to C. Okay, so write when F is equal to C. Okay, what was the linear equation? 9 by 5. F is equal to 9 by 5 C plus 32. This was the equation. So if F is equal to C, that means instead of F you can write what? C. F is equal to C. So instead of F you can write C. C is equal to 9 by 5 C plus 32. Okay. So we'll solve this one. I'm taking this 9 by 5 C this side. So positive 9 by 5 C will become negative C minus 9 by 5 C. I have taken both C terms together. Okay. Plus 32. C minus 9 by 5 C equal to 32. So taking LCM here. Okay, here it is 5. So into 5, 5 is the LCM, into 5 into 5 to make the denominator same. 5 into C, 5C minus 9C. Denominator is same, 5, 5. So I can write 1, 5 here, common. Okay, equal to 32. 5C minus 9C. 9 minus 5, 4 minus 4C divided by 5 equal to 32. Minus 4C by 5 equal to 32. So what is minus 4C? This 5 will go this side. So divided by 5 will become into 5. 32 into 5. Minus 4C is equal to, what is 32 into 5? 160. C equal to into 4. So here it will divided by 4. 160 divided by, is it 4 or minus 4? It's minus 4. So what is 160 divided by 4? 40. Negative 40. Negative into positive. Negative 40. So you got C is equal to minus 40 degree. So you can conclude this one as hence minus 40 degree is the temperature which is numerically the same in both Fahrenheit and Celsius. This is the conclusion. So by this we have completed this exercise. Okay. So now you have a small example to be done in your page 76, example number 9. Okay. Read this one. Solve the equation 2x plus 1 equal to x minus 3 and represent the solution on a number line as well as a Cartesian plane. Okay. We'll do this one now. So the equation is 2x plus 1 is equal to x minus 3. 2x plus 1 equal to x minus 3. Okay. You can solve this one. I'm taking x terms together. So this plus x will become minus x. 2x minus x equal to minus 3. I'm taking this 1 this side. So positive 1 will become negative 1. 2x minus 1. 2 minus 1, 1. 2x minus x, x, 1x equal to minus 3 minus 1. Minus 3 minus 1, 2 negative. So you'll add it. 3 plus 1, 4 and put the negative sign. So you got x is equal to minus 4. Can you represent this on a number line? X is equal to minus 4. Note this is the answer we got. X is equal to minus 4. You can represent this on a number line. See, this is your number line. 0, 1, 2, 3, 4, etc. minus 1, minus 2, minus 3, minus 4, etc. So what was the value for x? X is equal to minus 4. Where is minus 4? Here. So this is your point. X is equal to minus 4. So you have represented it on a number line. Now can you represent it on a Cartesian plane? So for that you need y value, not only x. You need x as well as y value to represent it on a Cartesian plane, right? How can you add y value? X is equal to minus 4 is the value. So you can add y, x plus 0y is equal to minus 4, right? You can add y. 0y is what? 0. Okay. So I am writing the equation as x plus 0y equal to minus 4. Now I am taking some values for x and finding the value of y. First of all, I am taking what is if y is equal to 0? This value of y is 0. X is equal to, you can substitute in this formula, x plus 0 into 0 anyways 0 equal to minus 4. Then what is x? Minus 4. So you got the first value, minus 4, 0. First you write x value, minus 4, 0. Now I am putting, suppose x is y is equal to 2. Okay. Then what is the value of x? Substitute in this formula, x plus y is what? 2. Anyways, whatever is the value of y, anyways it is going to be 0 because 0 into anything is 0. 0 into 2 equal to minus 4. X plus 0 into 2, 0 equal to minus 4. X is going to be minus 4 only. So your next point is minus 4, 2. Yeah, 2 points are enough. Now we'll plot it in the graph. Cartesian plane. So you can draw like this. What was the points? Minus 4, 0, minus 4, 2. Okay. Now 1, 2, 3, 4. So the first point is minus 4, 0. X-axis minus 4. This is your x-axis. Where is minus 4? Here. Anything is on y-axis? Nothing. Y-axis is 0. So this is the first point, minus 4, 0. Now second one is minus 4, 2. Minus 4 and 2 on the y-axis. So where it is touching? Here. So minus 4, 2. You can join this line. When you join, you can see this line is parallel to the y-axis, right? So this line is parallel to the y-axis. Our next topic was equations of lines parallel to the x-axis and y-axis. Okay. So the equation we done was x is equal to minus 4. So you got a line parallel to the y-axis, right? Just now we got. It was the line parallel to the y-axis. So how can you conclude this? You can conclude the graph of x is equal to a. A means any value, okay? Any numbers, anything. If x is equal to a is the graph, the graph will be a straight line parallel to which axis? Parallel to y-axis. In the same way, you can write, if y is equal to any number a, the graph of this will be a straight line parallel to which axis? Reverse, parallel to x-axis. So note that if x is equal to a, the graph of x is equal to a will be a straight line parallel to the y-axis. The graph of y is equal to a is a straight line parallel to x-axis. So I think we have one more exercise, a small one. So come to exercise 4.4. First question. Give the geometric representations of y is equal to 3 as an equation in one variable in two variables. Okay. This is of the form what? Y is equal to a. Just now I have told you y is equal to a. The graph. What will be the graph of y is equal to a? It will be a straight line parallel to which axis? Reverse, x-axis, right? So we will be getting a straight line which is parallel to the x-axis. Okay, we'll do it. So they have given y is equal to 3. Okay. First sub question was you need to represent this as one variable. How will you represent? You represent it on a number line. So we'll draw a number line. 1, 2, 3, minus 1, minus 2, minus 3. So what was the question? Y is equal to 3. Simple. This is your point. Y is equal to 3. This is how you represent it on a number line. Now you need to represent it in two variables. Two variables means you need to get x value also. So y is equal to 3 you can change as 0x plus y is equal to 3. Right? Since x is not there, you can add x as 0x. 0 into x plus y is equal to 3. Now, when x is equal to 0, what is the value of y? See, when x is 0, 0 into 0 anyway is 0. So, therefore, y is equal to 3. This is your first point, 0, 3. Now, when x is equal to 1, what is the value of y? I am putting x is equal to 1, okay? 1 into 0, anyway 0. It got cancelled. Y is equal to 3. Again, y is equal to 3. So, your next point is 1, 3. You got 2 points. You can plot it. 0, 3, 1, 3. Okay. 0, 3 is the first point. 1, 3. Second one. Now, I am drawing a Cartesian plane. 1, 2, 3, 4. Minus 1, minus 2, minus 3. Okay. Now the first point is 0, 3. 0 is on x-axis, 3 is on y-axis. So 0 on x-axis means there is nothing on x-axis. 3 on y-axis. Here, this is your point. 0, 3. Okay. Now, 1 and 3. 1 on x-axis, 3 on y-axis. 1, 3. So you can join the line, join the points. You'll get a straight line. If you take any value for x, you'll get the same value 3 as y-axis. So you'll be getting a straight line. I've told you it will be parallel to the x-axis. See, this is parallel to the x-axis. Okay. So the second question. Give the geometric representations of 2x plus 9 is equal to 0 as an equation in one variable in two variables. Okay. Here our equation is 2x plus 9 is equal to 0. 2x plus 9 equal to 0. This is the equation. So you can represent it on number line. For that you need to get the value for x. 2x is equal to, this 9 will go this side and becomes minus 9. Then what is x? X is equal to minus 9 by 2. So you got a value for x. Can you solve this one again? What is 9 by 2? 4.5. Minus 4.5. So you got a value for x as minus 4.5. Now represent it on number line. X is equal to minus 4.5. Okay, I am drawing a number line. Okay, where will be minus 4.5? Between minus 4 and minus 5. Somewhat here, minus 4.5. So this is your x is equal to minus 4.5. This point. Now represent it on a Cartesian plane. So you need a y term in your equation. This is your equation, x is equal to minus 4.5. So you have added y term, that means x plus 0y equal to minus 4.5. This is your equation now. X plus 0y equal to minus 4.5. Okay. Now I am taking some values for y. When y is equal to 0, tell me what is x. Y equal to 0 means 0 into 0. This whole term got cancelled. What is the value of x? Minus 4.5. See, x is equal to minus 4.5. Now I am taking y is equal to 1. Okay. When y is equal to 1, what is the value of x? Anyways, 1 into 0 got cancelled. Again, x is equal to minus 4.5. So you got 2 points as minus 4.50. First write the x term. Minus 4.5, 1. So this is your 2 terms, 2 points. So we'll plot it now. Minus 4.50, minus 4.51. Okay. So I'm drawing a Cartesian plane. 2, 3, etc. 1, 2, 3, 4, minus 1, minus 2, minus 3, etc. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. See the first point. Minus 4.5 and 0. X-axis minus 4.5. So this is the x-axis. Where is minus 4.5? Between minus 4 and minus 5. Somewhat here. So this is your first point, minus 4.5, 0. Because y-axis 0. Okay. Now the second point, minus 4.5 and 1. That means x-axis minus 4.5, y-axis 1. Where is x-axis minus 4.5? Here. Okay. So 1 on the y-axis. Where it is touching. So this is your second point, minus 4.51. Okay. Join the points. So you'll get a straight line like this. Now you can see this line is parallel to which axis? Y-axis. This is your y-axis. So this line is parallel to the y-axis. That's why I told you, if x is equal to a, if anything is in this form, the graph will be a straight line which is parallel to the y-axis. Here instead of a, what we got, x is equal to minus 4.5. Okay. Anything of this form will be parallel to y-axis. Anything of this form, y is equal to a, will be parallel to x-axis. Yes. So now we'll just go through the summary part of this chapter. Okay. First one, an equation of the form ax plus by plus c is equal to 0, where a, b, c are real numbers such that a and b are not both 0 is called a linear equation in two variables. We studied that, right? This is a standard form of an equation, ax plus by plus c is equal to 0. So second one, a linear equation in two variables has infinitely many solutions. We have discussed that also. A linear equation in two variables will be having infinitely many solutions. Whichever value we put for x, okay, you will get corresponding value for y. So you have infinitely many solutions. Third one, the graph of every linear equation in two variable is a straight line. Right? For every graph we have plotted, you are getting a straight line. When you join those points, you are getting straight line. So you can conclude the graph of every linear equation in two variable is a straight line. This is an important point. Fourth, x is equal to 0 is the equation of y-axis. Y is equal to 0 is the equation of x-axis. We have seen that x is equal to 0. If x is equal to 0, see, if x is equal to 0, you'll get any value for y. Suppose y is equal to 3. When you plot that one, you won't get any value in x-axis. You'll be putting in value in y-axis. Like suppose this is 3. So this will be your point 0, 3. So is this an equation on y-axis? Right? So you can say if x is equal to 0, this will be an equation on y-axis. Suppose y is equal to 0. Consider y is equal to 0. That means nothing on y-axis. You'll plot everything on x-axis. Here, here. So this is an equation in x-axis. Right? That's what. If x is equal to 0, the equation will be on the y-axis. If y is equal to 0, the equation will be on the x-axis. Fifth one. The graph of x is equal to a is a straight line parallel to y-axis. Just now we have discussed this. Right? In the last problem. the graph of y is equal to a will be a straight line parallel to x-axis. 7th, an equation of the type y is equal to mx. Y is equal to mx. This is also an important point. An equation of the type y is equal to mx represents a line passing through the origin. We'll take an example. Suppose y is equal to 2x. This is of the form y is equal to mx. Instead of m, I've taken 2. So suppose this is the equation, y is equal to 2x. Same way, if x is equal to 0, y is equal to, see, you're putting x is equal to 0. 0 into 2, 0. So you're getting y is equal to 0. Right? You are taking x is equal to 1. Y is equal to 2 into 1, 1, 2. So x is equal to 1, y is equal to 2. If you want, take one more point. X is equal to 2, y is equal to, if x is equal to 2, 2 into 2, 4. So y is equal to 4. You got 3 points. 0, 0, 1, 2, 2, 4. We'll plot this one and see. 0, 0, 1, 2, 2, 4. When I plot this one, see, first point is 0, 0. That means here. 0, 0 will be here. So this is your point 0, 0. Second one, 1 and 2. That means x-axis 1, y-axis 2. Where it is touching. 1, 2. Now the third one, 2 and 4. 2, 4. 2 on the x-axis, 4 on the y-axis. 2 and 4. When you join the points, you can see this is passing through the origin. Where is the origin? This is the origin. So this line is passing through the origin. So any equation of the form y is equal to mx will pass through the origin. You can try whichever equation you want. Okay. So it will pass through the origin. Okay. So the last point is 8th one. Every point on the graph of a linear equation in two variable is a solution of a linear equation. Moreover, every solution of the linear equation is a point on the graph of the linear equation. See here, every point on the graph is a solution of the linear equation. See, if I put here a point, this is a solution of a linear equation. If I put here, see, if you extend this point, you are getting 2 points, right? So every point on the graph, any point on the graph is a solution of linear equation. Okay. Moreover, every solution of the linear equation is a point on the graph. Of course, every solution. See, if you take any solution of the linear equation, it will be a point on the graph. Right? Anything. 3, 4. This point is on the graph. 15, 4. This is also there in the graph. So you can say every solution of the linear equation is a point on the graph of the linear equation. Okay? So that's all. We have completed this chapter. Linear equations in two variables. So this is the end of the chapter. So be prepared with this chapter. We'll be conducting a test and also a quiz regarding this chapter.